Let's take the derivative of arc cosecant of x to the third. First, let's differentiate both sides with respect to x. So we have dy dx equals d dx of arc cosecant of x to the third. And notice that we have a function of x to the third nested within the arc cosecant function, which means we'd like to work towards using chain rule. To set ourselves up, let's say u equals x to the third, and dy dx equals d dx of arc cosecant of u. And now, since we have a function in terms of u being differentiated with respect to x, it is time to use chain rule. So dy dx equals du dx times d du of arc cosecant of u. And let's go back up here to evaluate du dx. So the derivative of u with respect to x is going to be equal to, we can just use the derivative power rule here and get 3x squared. So we have du dx equals 3x squared. All right, and we're going to multiply that by derivative of arc cosecant of u. We already worked that out in the main derivation video for arc cosecant. Derivatives is equal to -1 over u squared times the square root of 1 minus 1 over u squared. And we know from up top that u equals x to the third, so let's replace all of those u values with x to the third. Dy dx equals 3x squared times -1 over x to the third squared times the square root of 1 minus 1 over x to the third squared. Well, we just replaced x to the third here, so we keep this squared value. And next we can just multiply through. Dy dx equals 3x squared times -1 is going to be equal to -3x squared. And that's going to be all over. X to the third squared is going to be x to the sixth because we multiply exponents to the exponent, and times the square root of 1 minus 1 over x to the sixth. Same multiplication there. And then it looks like we can cross out x squared over x to the sixth is going to be equal to we have a -3 over x to the fourth, canceling out some of those exponent values, and we are done.